Welcome back to the Comptia Network Plus course. Identify symptoms. I probably don't need to tell you that computers and networks can be really fickle. They can hum along fine for months, suddenly crash, and then continue to work fine again without ever ceasing in that way again. That's why it's so important to be able to reproduce the problems and identify the affected area to narrow things down so you can cut to the chase and fix the issue fast. This really helps when something isn't working. Try it again and write down exactly what it is and is not happening. Most users' knee-jerk reaction is to straight up call the help desk the minute they have a problem. This is not only annoying but also inefficient, because you're going to ask them exactly what they were doing when the problem occurred, and most users have no idea what they were doing with the computer at the time because they were focused on doing their jobs instead. This is why if you train users to reproduce the problems and jot down some notes about it before calling you, they'll be much better prepared to give you the information you need to start troubleshooting it and help them. So with that, here we go. The problem you've identified results in coughing out an error message to your user when they try to access the corporate intranet. It looks like figure 19.1. So and when the user tries to ping the service hierarchical web name, it fails. See figure 19.2. You're going to respond by checking to see whether the server is up by pinging the server's IP address. See figure 19.3, and you can see here he's pinged the IP address 206.123.114.186, and the ping command worked. Nice, that worked. So to the server it's up, but you could still have a server problem. Just because you can ping a host, it doesn't mean that the host is 100% up and running, but in that case it's a good start, and you're in luck because you've been able to recreate this problem from the user's host machine. By doing that, you know that the URL name is not being resolved from Internet Explorer, and you can't ping it by name either, but you can ping the server IP address from your limping host. And when you try this same connection to the internal .laml.com server from another host nearby, it works fine, meaning the server is working fine. So you've succeeded in isolating the problem to this specific host. Approach multiple problems individually. You should never mix possible solutions when troubleshooting. When multiple changes are made, interactions can occur that muddy the results. Always attack one issue at a time and make only a single change at a time. When a change does not have a beneficial effect, reverse the change before making another change. Great, now you've nailed down the problem. This leads us to step 2. Step 2, establish a theory of probable cause. After you observe the problem and identify the symptoms, next on the list is to establish its most probable cause. If you're stressing out about it now, don't, because though you may feel overwhelmed by all this, it truly does get a lot easier with time and experience. You must come up with at least one possible cause, even though it may not be completely on the money, and you don't always have to come up with it yourself. Someone else in the group may have the answer. Also, don't forget to check online resources and vendor documentation. Again, let's go back to our scenario in which you've determined the cause is properly and improperly configured DNS lookup on the workstation. The next thing to do is to verify the configuration and properly reconfigure DNS on the workstation. We'll get to this solution later in step 4. Understand that there are legions of problems that can occur on a network, and I'm sorry to tell you this, but they're typically not as simple as an example we've been using. They can be, but I just don't want you to expect them to be. Always consider the physical aspects of a network, but look beyond them into the realm of logical factors like the DNS lookup issue we've been using. Question the obvious. The probable cause that you've got to thoroughly understand to meet the Network Plus objectives are as follows: port speed, port duplex, mismatched MTU, incorrect virtual local area network, VLAN, incorrect IP address, a duplicate IP address, wrong gateway, wrong DNS, wrong subnet mask, incorrect interface misconfiguration, duplicate MAC addresses, expired IP address, rogue DHCP server, untrusted SSL certificate, incorrect time, exhausted DHCP scope, blocked TCP UDP ports, incorrect host space firewall settings, incorrect ACL settings, unresponsive service. Let's talk about these logical issues which can cause an abundance of network problems. Most of these happen because a device has been improperly configured. Port speed. Because networks have been evolving for many years, there are various levels of speed and sophistication mixed into them, often within the same network. Most of the newest NICs can be used at 10 Mbps, 100 Mbps and 1000 Mbps. Most switches can support at least 10 Mbps or 100 Mbps, and an increasing number of switches can also support 1000 Mbps. Plus, many switches can also auto-sense the speed of the NIC that's connected and use different speeds on various ports. As long as the switches are allowed to auto-sense the port speed, it's rare to have a problem develop that results in a complete lack of communication. But if you decide to set the port speed manually, make positively sure to set the same speed on both sides of a link. Port duplex mismatch. There are generally 3 duplex settings on each port of a network switch: full, half, auto. In order for two devices to connect effectively, the duplex setting has to match on both sides of the connection. If one side of connection is set to full and the other is set to half, they're mismatched. More elusively, if both sides are set to auto but the devices are different, you can also end up with a mismatch because the device on one side defaults to full and the other one defaults to half. Duplex mismatches can cause lots of network and interface errors and even a lack of network connection. This is partially because setting the interfaces to full duplex disables the CSMACD protocol. This is definitely not a problem in a network that has no hubs and therefore no shared segments in which there could be collisions, but it can make things really ugly in a network where hubs are still being used. This means the setting you chose are based on the type of device you have populating your network. If you have all switches and no hubs, feel free to set in all interfaces to full duplex, but if you've got hubs in the mix, you have shared networks, so you're forced to keep the settings at half duplex. With all new switches produced today, leaving the speed and duplex setting to auto, the default on both switches and hosts, is the recommended way to go. Mismatched MTU. Ethernet LANs enforce what is called a maximum transmission unit, MTU. This is the largest size packet that is allowed across a segment. In most cases, this is 1,500 bytes. Left alone, this is usually not a problem, but it is possible to set the MTU on a router interface, which means it is possible for a mismatch to be present between two router interfaces. This can cause problems with communications between the routers, resulting in the link failing to pass traffic. To check the MTU on an interface, execute the shown interface. Incorrect VLAN. Switches can have multiple VLANs each, and they can be connected to other switches using trunk links. As you know, VLANs are often used to represent departments or the occupations or a group of users. This makes the configurations of security policies and network access lists much easier to manage and control. On the other hand, if a port is accidentally assigned to the wrong VLAN in a switch, it's as if that client was magically transported to another place in the network. If that happens, the security policies that should apply to the client won't anymore, and other policies will be applied to the client that never should have been. The correct VLAN port assignment of a client is as important as air. When I'm troubleshooting a single host problem, this is the first place I look. Incorrect IP address, duplicate IP address. The most common addressing protocol in use today is IP version 4, which provides a unique IP address for each host on the network. Client computers usually get their addresses from Dynamic Host Configuration Protocol (DHCP) servers, but sometimes, especially in smaller networks, IP addresses for servers and router interfaces are statically assigned by the network's administrator. An incorrect or duplicate IP address on a client will keep that client from being able to communicate and may even cause a conflict with another client on the network. And a bad address on a server or router interface can be disastrous and affect a multitude of users. This is exactly why you need to be super careful to set up DHCP servers correctly, and also when configuring the static IP addresses assigned to servers and router interfaces. Wrong gateway. A gateway, sometimes called a default gateway or an IP default gateway, is a router's interface address that's configured to forward traffic with a destination IP address that's not in the same subnet as the device itself. Let me clarify that one for you. If a device compares where a packet wants to go with the network it's currently on and finds out that the packet needs to go through a remote network, the device will send that packet to the gateway to be forwarded to the remote network. Because every device needs a valid gateway to obtain communication outside its own network, it's going to require some careful planning when considering the gateway configuration of devices in your network. So I'm going to end here today for this video. If you like listening, please consider like, sharing, subscribing. Thank you.